Hello students, I am Farida and we are going to discuss today chapter number 8 Maharashtra State Board HSC Physics Electrostatics. In this particular chapter we are discussing the topic electric potential and potential energy. This is very interesting and important chapter in which you should know what is potential energy and what is electric potential energy. So before understanding electric potential energy and electric potential, we should know little about the potential energy. So we'll see what is potential energy. To understand this, we will see here some examples, some simple example with the help of which we can understand what is potential energy. Now in the first figure, we can see the hammer hold in the hand. At some height it is. In the next diagram, you can see the rubber band is stretched. And in the third figure, you can see the spring is compressed. Now in all the activities which are shown in the figure or diagram or picture, the hammer, the rubber band and the spring are storing some type of energy, and this energy is known as potential energy. Okay, energy stored by the hammer, energy stored by the stretch rubber band, and energy stored by the compressed spring. This energy is stored in the hammer, rubber band and spring is due to their relative positions. Due to height, the hammer is having the potential energy. Due to stretching, a rubber band can store energy, and due to compression, the spring stored the potential energy. It means these things are having the potential energy stored in them due to their positions or configurations. Now any position of that thing or any configuration of that thing possesses its potential energy. Now if we change the position or if you want to change the configuration, the work is to done. The work is to be done. The work is always required to be done to change the configuration. Okay, why we need the work? To change the configuration. So now here we can show you with the help of formulae. So what is work done? Work done we saw in the with the formulae we know how what is the definition of work done or formula for work done. Work done is nothing but, we'll write here, work done, that is equals to highest force into displacement. Okay, force into displacement. So whatever work is done by the hammer on the nail, due to that work done, the nail will displace over there in the table. So this work is known as potential energy. So work done is nothing but potential energy. Work done is always stored in the form of potential energy. Potential energy. Okay. Now, for example, we will see this example of hammer. Uh, in case of hammer, the work done we can write here, that is work done is equals to, how will write, the force into displacement. As we know, this is force into displacement. Okay, displacement we will show by later. D, now work into displacement. So what is force here? Force is against the acceleration due to gravity, so it is mass into acceleration. Here in this case we are considering it m into g, and whatever displacement is there, it is nothing but the height. From this to this it will displace, so into height we will write. So it is equals to mgh, and this is called work done, and this much work done is stored in the form of potential energy. So work done is nothing but potential energy, so we will get the formula of this potential energy, that is equals to mgh. With a simple example we can understand here what is potential energy. Okay, so now we will relate this with the electrostatic potential. So what is electrostatic potential, and what is, or electric potential we can call it, electric potential energy and potential, that we will see. So here we will discuss electric potential, potential and electric potential energy. Okay, so again to understand this we will see the simple diagram here. Let us consider here two different charges or two similar charges. When two charges are kept near to each other, if they are similar in nature, okay, positive and positive we are keeping near to each other, then repulsive force will be there. Okay, and if those charges are different in nature or dissimilar, then there is a force of attraction between them. So this force of repulsion or force of attraction is called the electrostatic force of attraction or repulsion, or it is called the electrostatic force. Okay, so now any charge, either it is positive or it is negative, if we are taking, there is a electric field around it, there is a electric field around it, and if the another charge is kept near to it, there is repulsion or attraction, depends upon the nature of the charge. So now to understand it in better manner, we'll see the next diagram. Let us consider here the charge Q, capital Q we are taking, and around it the electric field is there. Now the small charge, test charge we have taken here, that is Q0, positive test charge is kept at position A. Now remember, whenever the charge is kept at the position, this is the natural phenomena that every system tries to attain the lowest potential energy. Okay, lowest potential energy. So if the position of Q0 is here, it has some energy over there. Okay, so if you want to change the position or if you want to change the configuration, that time work is required to be done to change the configuration. Okay, let us consider now this charge q and the small test charge plus q we are taking here. The distance between them is r. Now if we want to change the position of q0 from a to b, let us consider this distance from a to b is small dr. So to cover this small distance dr, the force is required, and that force uh, should be same in magnitude and opposite in nature of the electrostatic force, because this there is a repulsion between these two charges, and that repulsive force is electrostatic force of repulsion, that is denoted here by F. Okay, so now here it is denoted by F. So we are applying force which is same in magnitude but opposite in nature. So whatever force is applied to it to move the Q0 charge from this place to this place, from A to B, okay, then that time work is done. Okay, so now consider here a small, to cover a small distance dr, we required some force, and that is equals to F in magnitude. Okay, F is here F dash. If we are taking this force, so it will be same in magnitude but opposite in direction. Okay, so here suppose this is F, this is F1 force we are applying, which is equal in magnitude of this F, but direction is opposite. So how much distance it is covering? Some dr distance it is covering from A to B. So work done is nothing but, we know the formula for this. Work done is equals to force into displacement. Force into displacement. Okay, so here which force we are using here? That is F, same here. Displacement is how much? It is dr. So work done is equals to F into dr we are taking. This much displacement we are taking, and this is also force in magnitude we are taking. Sorry, here I'll write the force into displacement. So minus sign shows the direction of this forces in opposite with the electrostatic force. So what it is actually? In first case we saw here, that is force into displacement is work done, and that is equals to potential energy. So here also we can write that is equals to potential energy, isn't it? So work done is equals to this, and this is equals to potential energy. Now this small distance it is covered, so whatever work is done, that is also small, so we are denoting it by small letter d. So work done is equals to du, and that is equals to, now we can write this as F into dr. So in this way we got the electric potential and electric potential energy. It is denoted by dO. So electric potential is here PE, not PE. Here you can denote as electric potential. And that is equals to F into dr, and that is equals to the change of energy, change of potential energy. Now you can see here, this is A position and this is B position. So from A to B, if it is coming, then we can say it is covering some distance dr, and so the work done is equals to F into dr. So in this lecture, it is we will stop here, and in the next lecture we will start with the new interesting things about this potential energy and electric potential and electric potential energy. Thank you.